I'm Mert. I'm the CTO of Applied AI. Today, I'm going to talk to you about quantifiable AI. The outline will be a quick look at the current state of AI and what happened in the past 20 years and how it's going to look in the future 10 years, let's say. And then I'm going to move on to describe how to define a piece of AI work, then how to vet a piece of AI work. And afterwards, I'll display where our company stands and how we use AI internally. So let me switch to the slides and I'll move on from there. Here's my background. I have a computer engineering bachelor's at Boğaziçi University. At there, I've taken additional machine learning courses from the graduate level. Then I went on to do an AI bachelor thesis. My topic was on recurrent neural networks, and I examined LSTMs in depth. I worked with Shakespeare's poems and some of his plays and generated new text. So moving on, I started a master's program at where I started studying deep learning. And with other grad students, we started a deep learning reading group called Deep Balloon. And I've given several talks around the neighborhood. One was titled Learning to Learn, and the other was titled how machine learning affects our daily lives. So my additional background is I have developed Android for 4 years. I have developed games for a year. I have 2 years of web development experience. I worked at a bank as a machine learning consultant. And for the past 5 months, I have been the CTO of Applied AI. So here is the outline of my talk, as I mentioned earlier. So, past, present, and future of AI. The AI landscape has shaped dramatically in the past 10 years. The money pouring into the AI sector has increased dramatically. So here is the report by CB Insights. They have listed the quarterly investments, which are publicly disclosed. So here we can see around $1 billion per quarter. It has been increasing per year. This is a quarterly average, and if you take the yearly average, of course, it's increasing. So let's look at the computation. The Moore's law states that every 18 months, our computation power doubles. And here is the updated version, which has been published in the last year. And the law has been holding, but the pace has slowed a little bit. I've said 18 months. Previously, it was every year. But the improvement continues. We might be reaching the physical limits of the hardware. Our transistors have been getting smaller and smaller, but of course there's a limit. And let's look at a case study here. LSTM is a model, a recurrent neural network model that was proposed in 1997 and further improved in 2000. It was a really simple improvement to the recurrent neural networks. It added a memory cell to the recurrent node. So what it does was it introduced learning and forgetting. Here are the equation details for the interested. This is the output of the cell. This is the previous state of the cell, and there is the input data. So there is an internal cell state here. And it is being updated over time. and a cell may decide to forget or not forget the previous information that it's holding. And below are the search term results of LSTM. It has skyrocketed in the past years. This is the ImageNet challenge has improved great interest in the deep learning field by AlexNet, the clever use of CNNs. And further on, when the industry discovered the computation powers usage in deep learning, several older algorithms have surfaced, such as LSTM here. I mean, it has been introduced 20 years ago, but today, only today, it has been integrated in our daily lives. Our phones are using it, our computers are using it. So why now? There has been a tremendous increase in computation power. There has been tremendous increase in investment in the sector. So chance to see the results of these investments today. And not only investment, but we have seen outcomes in the area too. For example, self-driving cars. The popular taxi replacement company, Uber, have been utilizing self-driving cars for their passenger transportation in San Francisco. What does this mean for drivers, for example? It's not a bad prediction to say that in 20 years, most of the drivers will be eliminated. Same goes for other jobs too. Bank tellers. You will be using smarter automated teller machines, and you wouldn't be needing bank tellers. Cashiers. We are already seeing self-checkout systems in the retail stores. Or let's say the advancements in 3D printers. By using cement placement, we are today are able to build houses using only 3D printers, and we no longer need construction workers. And let's consider farming. There has been many improvements in IoT devices. Today, you can install a self-maintaining system for your farm. You can just buy the kit, install in the land, and just collect the fruit or vegetables, but only using robots. What else? Translators. Here's a GIF of the Google Watch. It asks for the sound input, and boom, there's a translation. If you go to a foreign country, you can just use your earbuds they have recently announced or your phone, and you wouldn't need any translator there. And same goes for analysts, accountants, because these are the jobs that can be automated easily using advanced machine learning techniques. So, what is artificial intelligence? These are the quotes by John McCarthy. He says, it's the science and engineering of making intelligent, especially intelligent computer programs. So you want to have your machine intelligent, but what is intelligence? And he goes on by saying, intelligence is the computational part of the ability to achieve goals. So artificial intelligence means smart machines that complete tasks. But is every machine that is able to complete a task an artificially intelligent machine? Or what is artificial intelligence in that setting? There's a popular argument known as the Chinese room argument. The outline goes like this. There are two Chinese guys, and there's another guy in the room who doesn't know Chinese, and he gets the questions in Chinese, and he outputs the answer in Chinese. But he has no idea about Chinese. What he has is a rule book. The rule book is written in English, and he can map the questions to answers using that rule book. From the outside, You can only see that you are inputting a question and you are getting an answer. But from the inside, the inner state of the machine, in this case, an Englishman, has no idea about the question nor the answer. So, is this man artificially intelligent, or is this machine artificial intelligence? It depends. It depends on the task. So, some tasks can be solved using a rulebook, and you can infer results using a rulebook. For example, if the question is, "Are the grass wet?" So you go to your first question. Is it raining? Yes. If it's raining, then the grass is 95% wet. If it's not raining, you check the sprinkler. If the sprinkler is on, the grass is 90% wet. If it's not, it's 10% wet. Of course, these numbers are inferred by previous data, but you get the idea. So, an AI is as good as its training data, test data. So let's go into details. Let's say you want to be able to determine if a baby is crying because of he or she is hungry or tired or has toilet issues. How can you know? You can collect crying data. You take out your phone, you record your baby's crying noise, and if you know why your baby is crying, you label it. This has been done before. There has been a publicly called data gathering activity. 5,000 sounds has been collected. There were 8 categories, I believe, and most of the labels were around 50% were hungry. So this is a really bad distribution among classes. Later on, if you if you train your network on this training data, then you get a really unevenly distributed model. With a chance of 50%, if you say the baby is crying because he or she is hungry, you will be right. And the models that were trained on this wouldn't perform as you would expect. We have done this at our university, and we were only able to achieve 60% of accuracy. I would say this is not a very good model because the training data it was trained on was imperfect. So let's look at another example here. Let's say you want to determine if you want to wear a sweater or not. So you look at the temperature. But, sorry, let me rephrase this. You want to have an artificial intelligence entity that would tell you to wear a sweater or not, depending on the temperature outside. So if you're living in, let's say, Alaska, that threshold temperature may differ from the rest of the world. Or if you're living in the Ecuador, you wouldn't even need to wear it. So there is no general artificial intelligence entity that can answer this question. You need to introduce bias, you need to introduce more variables, and you need to have better training data. Because let's say you only work with people that prefer not wearing a sweater, regardless of the weather conditions. Then you apply this model to the rest of the world. You would have terrible results because the data that you have trained on and the data you test your model with is irrelevant. So you need to have a good sampling of the world for both your train and test data. And a model is as good as its number of assumptions, because the more you assume, the less you are able to generalize. And the next thing here, computation power, goes for the current deep learning networks. Because, for example, an algorithm that was introduced in 2016, WaveNet, required 2 weeks of training to get one calculation. Later on, in 2017, Google improved this by a lot, and today Google Assistant uses WaveNet models for its sound recognition systems. So the advancement in terms of time and in terms of achievements is really amazing. And let's talk about accuracy and precision. So with low accuracy and low precision, you would be just shooting randomly. But with low accuracy and high precision, you would be shooting consistently, but would have terrible results. With low precision or high accuracy, you would be generally around the sweet spot, but you would still be missing. For a good AI, you need to have both. So to sum up, it really depends on the context and expectations. If you are trying to solve a problem that generalizes for the whole world, you need to collect data accordingly. If you want to solve a problem that only applies to a set of conditions, you have to work only in that context. So if you were to define what is a good AI and what is a bad AI, you need to have a lot of assumptions, you need to have a lot of information about the context, and you need to know what you want to achieve. So this is what you have to consider when you are weighing a piece of AI work. Let's say you are working at a computer vision company, and you are taking bottles that are in the retail store. Let's say there are Coke cans, there are Sprite cans, and there are fruit juice cans. And a general computer vision algorithm would perform poorly on this model, on this data. So you need to tailor for your needs, and you can't just go out and talk to any company and expect them to solve your problem, because you have a different problem from the previous work, you have a different problem from the rest of the world, and you want different outcomes. So where does applied AI stand in all of this? Let's talk about the functions that are used in the industry. There are marketing, IT, sales, operations, healthcare, HR, and fintech. There are lots of different companies that are specialized on different topics. Very little amount of them are working on different functions. Each of them are specialized in different industries. So we are categorizing them. So let's explain the taxonomy first. A company means a big company that is going to get consulting from an AI company. An AI company means vendor here, because they are selling their AI work. And a use case is the task they are working on. For example, they might be working on the retargeting use case, which means if users have previously shown interest in your work, you can retarget them by engaging them differently. This might work for an e-commerce company or a coffee company like Starbucks. You might be giving different promotions for different customers. And these types of work are classified as retargeting. So in order to be able to vet them, we are collecting data from these vendors and companies. Generally, they are listing these references on their social media sites or websites. So let's say you have worked with Coca-Cola. It's a big company for a small AI company. You would definitely list them. And let's say an outsider comes and looks for an computer vision consulting from an AI vendor. And he or she wouldn't be able to decide on which vendor to work with, because today there are loads of AI vendors. This is just a small subset of the whole world. It's expected to be 2,000 major players in this world. So the better thing would be seeing previous examples of their work. You can, of course, ask them, but if you ask a vendor for their previous work, of course, they are going to be providing the best ones. And you want to have testimonials. You want to have previous results. For example, how much improvement did you see in your sales by you working with this vendor? Therefore, as applied AI, a part of our work is gathering information about these references. And there's an assumption, of course. We are assuming that a company is listing their reference on their website. Well, it's a fair assumption, and it seems to work. For example, this is a screenshot from one of the vendors, and they have worked with many large companies. So, of course, this is not the whole part of our work, but we are trying to automate this part because gathering references is a hard thing. We need to go to the vendors and ask them to manually enter their reference. We are already doing that, but it needs to be automated because there are lots of companies, there are lots of vendors, and of course they have more important jobs to do, like closing sales. Here's the problem. You want to know if a company is working with a vendor, and you are assuming that they have listed this on their website. Cool. Now you go to their websites and you get all the images that they are showing. But not every image is a logo, and not every logo is a reference. Let's leave the second part for later. So you have, let's say, hundreds of images, and only 2 of them are references because on a website there are lots of things. So let's say you want to determine the logo of Slack on a company's website. But logo of Slack is not unique in every context. Sometimes they are using the monochrome version, sometimes they are using the inverted version, they are using different colors. So there are more augmentations to be done in order to be able to match the logo of Slack. We are trying to gather every logo they are presenting. This is from their website. They have listed all possible augmentations of their logo. And even our logo has different versions. We have the normal one, we have square one, we have the inverted one, etc., etc. So generally, image recognition task is a lot harder because the context that the images use generally obscured. For example, look at the Adidas logo here. It's behind the shoe and it's skewed. Luckily, for our task, all of the logos are presented nicely. But there are issues like the color and inversion and orientation of text and logo, as I mentioned. So what we are doing is, for example, for Slack, we are getting every possible logo here. Then let's assume that we have started with Siemens. We are getting the logo and we are shrinking it down because for tests like this, high resolution logos really doesn't matter. In the end, this is just a small image that is at most 200 by 200 pixels. Later on, we are using different augmentations of the logos. We are rotating it, we are inverting it, we are playing with its colors, we are using grayscale. Here are some examples about the on the logo we have used on Siemens. Then we are using TensorFlow, by the way. We are training a deep neural network. There are some previous work that has been done on this topic. There are some example neural networks. What we are doing is we are trying different archetypes. First, we shrink the logo down by 64 by 64 pixels, and 64 here is just a parameter. We are using 128 to 56 and 512. Later on, we are using 3 layers of neural networks. Each layer consists of a CNN. And in this CNN, we are super sampling the pixels, and as far as I remember, our network size would be 256 in each layer. So for each logo, let's say we have started with a pool of 1,000 logos, and we want to know if a company is listing Slack among their logos. For Slack, we have a precision score. Let's say we have gathered this logo, Mitsubishi's one, and we are comparing to model of Slack. If we get a high enough precision, we are going to propose that that this logo is Slack. We are running these crawlers for 24 hours because there are lots of computation to be done. But we currently only use automatic logo detection. We do not automatically insert these predictions to our database. Instead, we generate a list of proposals and manually verify them. Since costs of false positives are high for our business, because we are listing these references in our website. If we show wrong references that has never happened, both of the parties would be met. What we are using is, let's say, we are proposing that this vendor is working with this company, and next to that, we are including a screenshot of the reference. Therefore, then we can manually check that if really that logo is included on the website. And of course, we can look at the context. What we are planning to do next is we are going to use NLP and crawl all the text surrounding the image and look for words like reference, testimonial, partner. These are the keywords that we ought to look out for. And of course, the negation words play a good role, because sometimes companies are only listing news on their websites and not references. So this is how we are using artificial intelligence at our company, and this is what you have to look out for while working on real-world cases. Now I'm going to switch back to the presentation mode, and I'm going to answer any questions you have. So Raghav is asking, how many examples of logos do you have for each case? So as for the Slack example I mentioned, there were different variations of the logo. And we are using these variations at a starting pool. Then we are using the augmentation techniques that I explained. We are rotating them, we are skewing them, and let's say we might have hundreds of logos then. Later on, we train the classifier on that set of logos because it's a yes or no questions when you scope it down to a single logo. So let's say one model is a classifier for only a logo. So I look at a new picture and decide that if it's a logo of Slack or not. And we ask these questions for each of our companies and vendors. So that's how we do it. So Lurb is asking that how are we dealing with the detection of a screenshot? You don't need to work with screenshots. There are different kinds of web crawlers. You can say that go to this website and get all the images from there. So in the end, all you have is JPEGs and PNGs. You needn't worry about screenshots. The screenshots we are including are only for manual work, because a member of our company is going to check if that reference is valid or not. It's just for easing the work. So how much manual work is required? I mean, it only takes 30 seconds to confirm or not. If there's a long explanation, of course, you need to be more careful about it. But generally, they are just listing the references in a list or grid, so it's easy. Florentin asking, do you spend most of your time cleaning and transforming data? No, because we are crawling all images from the website, and that's our data that we're testing on. There's no need for cleaning for that. And as for logos, when you go to a company's website, you can just get their logo there, or you can use Google. And we have a separate system at applydai.com that we ask for vendors to upload their own logos. So most of our logos are clear, correct version of them. And if we have not satisfying results, of course, we look out for more logos, but it's really a small part of the whole equation. Ansu is asking, which deep learning framework are we using? We are using TensorFlow, as I previously stated. Ragav is asking, I'm doing food detection, and usually the food in the plate is cluttered, unlike the logos, which are clearly separated. So how do I deal with the cases when logos are sometimes overlapping? So if you are trying to detect things that might be overlapping, you need to have proposals for regions. The first task is detecting regions. Let's say you are doing face detection. There are face detectors that you use as the previous step before detecting the face. Or let's say you take a picture of me. The first thing you do is frame my face. Later on, you can determine whose face is that. So in terms of foods, I mean, if the foods are scattered all around the plates, it wouldn't be nice. But I believe you are working with cleaner versions, so you might try to propose regions for that. So you might use the white space and first determine where are the clusters of food. Then later try to determine which food is there. Yasin is asking, how often do you retrain your model based on new examples? So our models are trained on logos. So for a set of logos, we only need to train the classifier once. After that, we have a classifier for that logo. And that classifier only answers the question if the input image is a class of that logo or not. So if we have new data, of course, we will update the models, but we don't retrain the model entirely. We just propagate from there. So this is called fine-tuning in the domain. You start from a good starting point, then you scale accordingly. Let's say for a hill climbing analogy, you're trying to climb to the tallest mountain in the area, or the tallest point in the area. You start from the tallest mountain and go up from there. And that's what starting from the previous point means. How many deep learning guys do you have? Currently, we have outsourced some part of work, but 2 or 3. Ansu is asking, your logo detection algorithm, is it based on some state-of-the-art algorithm like RCNN, SSD, YOLO? So we are not using YOLO. We need to have more precise results. I believe we've used ResNet, and I mean, for images that small, you can just use plain CNNs. Of course, we are experimenting with different sets of models, and we choose the one that suits most for the logo. Some logos are more complicated, some are not. For any task, you are better off by comparing the models with different algorithms. So that's what we're doing. Any recommendations about anomaly detection in video streams? To detect abnormal activity, probably security. So last year, I have attended a conference. Some guys from Israel were shortening video security tapes. They were omitting the non-active parts and just generating a 1-minute summary, depending on a 24-hour of tape. So anomaly detection in video is a more complicated problem, of course. You would need to be able to define what is normal. I mean, if there is an on-point schedule and you know what's happening every minute, that would be easier. But for abnormal activity like theft, I don't know, you need to check more state-of-the-art solutions, I believe. It's a much more difficult problem than logo detection. How long do your model typically train? Sorry. And what type of computing hardware are you running on? For starters, we have used our onboard CPU, but of course it was enough. Then we switched to onboard GPU. Then after we got that model working and we were sure that it was working, we moved on to Amazon's AWS services. So any computer with GPU that you can run TensorFlow on or other open source deep learning framework, it's fine. If you want quicker results, of course, you need to pay more money. But if you're training a classifier that is not going to change and it's not a real-time system, you needn't worry about that, because there are more open source platform as a services, not open source, sorry. There are more platform as a services. For example, I've heard about Floyd Hub that is tailored for deep learning on the cloud, that you can just get around by using that. Sorry, Raghav, I can't talk about the revenue we are generating. Once you detect the logo in the image, let's say there are two, you cropped it, how do you deal with recognition? I assume you use a representation of it. How can you guarantee a minimum precision? Or for each one, you have manual labeling of the nearest neighbors. So for any logo we get, actually, we don't need to crop the logos. We already have cropped versions because logos are uploaded individually. There are really, it's not, we often don't see logos crawled together. For example, one infographic I showed on the slides was stamped with logos, but generally we don't need to crop it. Let's say, okay, let's say we have cropped it. A minimum precision, well, I believe we set the threshold by hand. It was 95% of accuracy. If we are 95% of sure that that logo is correct, we are generating a proposal. And to remind you, we are not using automated insertion. We are doing extra manual check, which takes really a little amount of time. So we don't manually label nearest neighbors. We just look at the result and check yes or no. So all we call as deep learning research has reached the plateau state, so the topic might be in a state of maturity enough to get useful results in the industry. What have you noticed in this regard? So deep learning research, I don't believe it has reached the plateau state. More and more advancement has been happening. The LSTM model was introduced in '97, and usage and improvements on it has happened in the last 5-6 years. Every year we hear about, or let's say every month, we hear about a new paper that is very promising and generates tremendous results. And when a large company adopts that algorithm and scales to the large level, the effects are tremendous. So we are already getting user industry. I don't think it has matured yet. I think we are just at the beginning. Why reference scrolling is an interesting business case for the customers. So think of the company's perspective. You want to work with an AI vendor, but for a single task, there are, let's say, tens of AI vendors working on that same task. And they come knocking at your door. You don't know which to work with, and you need to be able to decide which to work with. So you need to look at their past work, and you need to look at their past references. So that's why. All right, I think my time is up. Thank you all for listening, and goodbye.